हेलो दोस्तों, कैसे हो आप सब। आई होप कि आप सब ठीक होंगे। तो आज हम डिफरेंशिएशन करने जा रहे हैं tan x की बाय एबनिशियो मेथड और बाय फर्स्ट प्रिंसिपल। फॉर दैट लेट्स स्टार्ट solution. We have given function that is y is equal to tan x. This is our given, and we are going to find its derivative. As we already know, in general we can write अगर हम इसकी डिफरेंशिएशन जो इसकी बनती है that is dy divided by dx comes out to be sec square x, but we are going to prove this dy by dx y is equal to tan x by ab initio method. We are going to prove this sec square x differentiation of tan x by ab initio method. Let me mark this here. For that, let's go. As we already know, we can write here uh, y plus delta y, the small increment, the small change in y, that is y plus delta y. But this is only possible small change when we change x, because x is independent variable, and when we change independent variable, when on that basis our dependent variable changes. That's why we can write here tan x plus delta x. Now we already know this tan x, as we know, if I can write here, as we know, this tan x is equal to sin x divided by cos x. We know this identity. Now we can use this here also. Now let me rub this. Thus I can write y plus delta y is equal to tan of sorry, अब मैं यहाँ पे लिखूँगा. Now we can write tan in terms of sin and cos. Sin of x plus delta x divided by cos of x plus delta x. All right. Now it's all right. मैंने यहाँ पे tan चेंज किया sin और cos में. Now the next step is I can write delta y, the change in y. I'm not talking about the rate of change. I am simply talking about the change in y. That is delta y. That is sin of x plus delta x divided by cos of x plus delta x minus times this y. Now I can write delta y is equal to sin of x plus delta x divided by cos of x plus delta x minus y. This y is our given, that's tan x, but I can write tan x in terms of sin and sin x divided by cos x. All right, we can write this in terms of sin, ratio of sin and cos. Till now it is all right. Let me rub this side. Now see here, I can again rewrite this step, that is our last step, that is delta y is equal to sin of x plus delta x divided by cos of x plus delta x minus sine of x divided by cos x. All right. Now let's multiply this, cross multiply. And we get delta y is equal to this becomes sine of x plus delta x cos x when we multiply this minus times let me write this in a good way. मैं इसको चाहूँगा कि ये इसी लाइन में सारा आ जाए, तो मैं यहाँ पे लिखूँगा साइन ऑफ एक्स प्लस डेल्टा एक्स मल्टीप्लाई कॉस एक्स minus when we multiply this that becomes cos of x plus delta x and sin x. All right, divided by this whole term, that is when we multiply these denominator terms, this becomes cos of x plus delta x into cos x. As we already know, we have a trigonometric function. आपको पता होगा कि हमारे पास एक trigonometric function है, पहले मैं उसको लिखूंगा यहाँ पे. See here, when we have sin of a minus b, अगर हमारे पास ये फार्मूला है sin a minus b, we can write this in this form, that is sin of a cos b minus cos of a sin b. ठीक, ऐसे यहाँ पे हमें दिखाई पड़ रहा है. आप इसको मानो a और इसको मानो आप b. ये जो एंगल है यहाँ पे ये हमारा a है और ये जो एंगल है it becomes b, and this becomes in this form, that is sin a cos b minus cos a, this is our a and this is our b, sin b. Now what we do here, we can rewrite this here. Our this formula is elaborated. Also we can write this in its actual form. तो हम यहाँ पे क्या लिखेंगे, इसके बदले हम ये लिखेंगे, that is sin a minus b लिख सकते हैं. This is, I can write in this way, delta y is equal to sin of a, our a is x plus delta x plus delta x minus b, our b is this x, and when we elaborate this formula, this becomes sin a cos b, that is sin a cos b minus cos a sin b. ये वापस में इस फॉर्म में आएगा, divided by this cos of x plus delta x into cos x. All right, now here we can cut this and this. This is minus, this is positive. I can write delta y is equal to, this becomes sin of delta x divided by cos of x plus delta x into cos of x. Now let me rub these above steps. Now I can rewrite the last step, that is delta y is equal to sine of delta x divided by cos of x plus delta x into cos of x. Now see here, you can write this in this way. अब यहाँ पे क्या है कि sin delta x divided by cos x plus delta x, that is cos of into cos of x. Now we can find the rate of change of this delta y with respect to x, and we divide both sides by delta x, that is delta y divided by delta x is equal to sine of delta x divided by delta x into 1 by cos of x plus delta x into cos x. All right, you can see here, this is our sine delta x. This delta x is multiply on the whole term, but I only divide this part, that is sine of delta x divided by delta x, because uh, we'll see this becomes our identity. This becomes our some kind of formula when we approach limit. दैट्स वाई कि मैंने इसको इस तरीके से लिखा है, साइन डेल्टा एक्स डिवाइड बाई डेल्टा एक्स, इसी के नीचे मैंने इसको मल्टीपल किया है, वरना ये सब के बराबर मल्टीपल में है. And this is our cos of x plus delta x cos of x into cos x. Now let's approach this limit. Limit delta x approach to 0, delta y divided by delta x. All right, you can see here our sign limit delta x approach to 0, sine of x divided by delta x multiply by 1 divided by cos of x plus delta x into cos of x. All right, chalo. When we approach this delta x to 0, this becomes our instant rate of change, that is dy divided by dx, which is equal to, when we approach this limit delta x to 0, as we know, if we talk about this, let me write this, this delta x approach to 0 is this approach to this delta x and this delta x. Now as we know, our sine theta by theta, our sine theta by theta, when theta approach to 0, limit theta approach to 0, we know that when limit theta approach to 0, sine theta by theta becomes 1. अगर आपको ये पता नहीं है कि कैसे, कि आप मेरा इस पे ओल्ड वीडियो देख सकते हो, मैंने इस पर ऑलरेडी वीडियो अपलोड किया है, आप उसको देख सकते हो, तो वहाँ पे आपको पता चलेगा कि ये कैसे, जो ये आइडेंटिटी हमारे पास है, साइन थीटा बाई थीटा व्हेन थीटा अप्रोच टू 0, हाउ दिस इज इक्वल टू 1. You can see this there. You can search my videos in my video list. You can find this video where we prove this identity. Now let's use this here. Now from this identity we can write here, this becomes 1 by, let me write in this way, limit delta x approach to 0. Sorry, now also when we use this limit on this term, that is 1 by cos of x plus delta x, this delta x when delta x approach to 0, it becomes close and close to 0, and we neglect this value here, and when we neglect this, this becomes cos of x. Now when we multiply these two, this becomes cos a into cos cos x into cos x. This becomes cos square of x. Now I can write uh, in straight. I can write this becomes our 1 by cos square x multiplied by 1. This one comes out from this identity. Now dy by dx comes out to be that is dy divided by dx, sorry, dy divided by dx is equal to, that is 1 divided by cos square of x into 1. As we know, sine is equal to sine x is equal to 1 by cos x, and we can write this cos x, sorry, as we know, uh, this sine x is inverse to this uh, cosec x, 1 by cosec x, 1 by cosec x, and cos x is inverse to this 1 by sec x, and if we talk about tan x, that is inverse to this 1 by cot x. Now if we rewrite this in this form, we have 1 by cos square x. We can write this in this form, that's sec square x. Now put in this becomes our, that is dy divided by dx is equal to tan square sec square of x. Now this is our result. Now we prove this that y is equal to tan x, then dy by dx comes out to be sec square x. This is our proof of this tan x by this abinitio method. We can also prove this by another method. I can give hint of this another method. Now let me show this another method. You can also prove this by this method. That is our, as you know, our tan x is equal to sin x divided by cos x. Now we know this sin x divided by cos x, we can if we want to differentiate this, that is d divided by dx of tan x, we must differentiate this also, but this is in coefficient form. We can use coefficient rule. This coefficient rule of this is as you know, if we have u divided by v, we can use this coefficient rule in this way, that is v multiply u dash. U dash indicates here the differentiation of u, minus u multiply v dash divided by v square. So our coefficient rule. We can also use this on this sign on this question. Let me show you how. I can write this in this way. Cos of x, can write this in this way. multiply the differentiation of this sin x, this becomes uh, cos x minus, we can write sin, we can write cos x the same, sorry, we can write sin x same as it is, and the cos x, the differentiation of this cos x, this becomes minus sin x. When this minus sin x again, this becomes positive here, divided by cos square of x. Now you can see here cos square x plus sin square x divided by cos square of x. As we also know another identity of this cos square x plus sin square x, that is sin square x plus cos square x is equal to 1. We know this identity. Now we can use this here. Thus we can write 1 divided by cos square of x, and we know the reciprocal of this cos square of x becomes sec square of x. From this we understand the another method of this tan x. Now we know this tan x is equal to the differentiation of this tan x is equal to sec square x, and don't forget this. And if you forget this, you can solve it by easiest way. The second method which I discuss here, you can solve it by this way, because it does not take the much time. Another, in the next lecture, in the next discussion, in the next lecture of this, we will differentiation of sec x by this abinitio method. We can find out the differentiation of sec x by abinitio method. We will find all these differentiations of the basic functions, trigonometric functions, these logarithmic function. We can find all these by this abinitio method. For that, you must support us by like our video and subscribe our channel. Thank you so much. Thank you.